Teach a reasoning model to think better by copying a smarter teacher that has already seen the answer. That is on policy self-distillation, OPSD. It should work, and on most models it does. But on long chain of thought reasoning models, it consistently fails, marginal gains, often an outright drop. A team at Zhejiang University and Alibaba Tongyi shows why. Decompose the teacher's update into two pieces. One piece, the reference-induced part, is just the teacher memorizing the reference solution, something the student will never have at inference. The other, the inference-transferable part, is the genuine correction. And they show the reference part dominates. The fix is elegant. Build a reference-only teacher that sees the answer but not the question, subtract it off, and what remains is exactly the closed-form optimum of a KL regularized distillation. Across 8 model dataset cells, it beats both the base and standard OPSD every single time. The decomposition. The teacher's total update, log pi teacher minus log pi student, splits into two terms. First, the reference-induced update, delta ref, how much the teacher shifts just from seeing the reference, no question needed. Second, the inference-transferable update, delta it, how much it shifts when the question is added on top of the reference. Delta ref is memorization the student can never use. Delta, it is the wanted signal. If OPSD worked, the total update should align with delta it. To isolate delta it, build a reference-only teacher, the same base model conditioned on the reference alone, no question. Then, delta, it is just log pi teacher minus log pi reference. Now turn that residual into a distribution. The PMI target is proportional to the clean base policy times XP of delta it over beta. Beta 1 means full correction. Larger beta stays closer to the base. The reason this is not a hack. The PMI target is the closed-form maximizer of a token-level KL regularized distillation objective, the exact analog of the RLHF and DPO policy improvement step. Maximize expected reward minus beta times KL divergence to the base policy. The solution is 1 over z times the base policy times EXP of reward over beta. Substitute the reward with delta it and you recover the PMI target exactly. So the target is not an ad hoc renormalization. It is the optimal KL regularized target induced by the transferable reward. The base policy plays the reference policy. Delta, it plays the implicit reward. The diagnosis in 2 metrics computed across the whole vocabulary at every token. First, direction. The cosine similarity between the total update and delta ref stays high throughout training on both Quen 3.8b and R1 Distill 7b. On R1, similarity to delta ref climbs from 0.58 to 0.99 in the first 100 steps. The teacher persistently pulls the student toward the reference, not toward question-conditioned reasoning. Second, magnitude. The norm of delta ref over the norm of the total update consistently exceeds 1. The reference-induced component is larger than the total update itself, which means delta, it partially cancels delta ref instead of reinforcing it. At the very start, the wanted signal is actively anti-aligned cosine to delta it near minus 0.95. The headline, in one chart. OPSD PMI against the base model, average accuracy across AIM 2024, AIM 2025, and HMMT 2025 percentage points. Quen 3.8b plus 4.2 on DASD plus 3.3 on MathCoT. Quen 3.4b plus 2.5 plus 1.5. R1 Distill 7b plus 2.1 on both. OLMO 7b plus 1.9 plus 2.0. 8 of 8 model dataset cells beat the base, gains from 1.5 to 4.2 points. The same 8 cells also beat standard OPSD, every single one. Standard OPSD is not just weak, it is harmful. On DASD, it degrades 3 of 4 models on average. Quen 3.8b minus 0.9, Quen 3.4b minus 0.7, OLMO minus 1.5, only R1 near 0 at minus 0.2. On MathCoT, it gives a marginal gain only on Quen 3.8b plus 0.5 and degrades the other 3, OLMO suffering the largest drop at minus 2.3. The reference shortcut is a universal bottleneck for long chain of thought models, regardless of architecture or training data. The mechanism shows up in how the models think. Track epistemic markers, words like wait, maybe, perhaps, check. Under standard OPSD, Quen 3.8b's total count collapses from 73,000 to 40,000, wait from 27,000 to 10,000, maybe from 12,000 to 3,000, uniform. Suppression. R1 Distill instead explodes from 71,000 to 115,000, but almost all of it is the single token, wait, 34,000 to 83,000. That is degenerate repetition, not deliberation. Under OPSD PMI, both stay within the 70,000 baseline range. It preserves how the model thinks. It does not just preserve the score. 3 honest caveats. First, the gains are modest in absolute terms, 1.5 to 4.2 points. The contribution is the mechanism and the stability, not a new state-of-the-art on math. Second, the evaluation is math only. 3 competition benchmarks, AIM-E and HMMT. No code, no science, no multi-domain long chain of thought test, so generalization beyond math is untested. Third, the decomposition metrics, the cosine endpoints and the norm fraction above 1, come from figure curve readings. Only the qualitative endpoints are confirmed in the text. And there is no benchmark against a well-tuned off-policy distillation baseline, so the practical question of whether OPSD PMI beats plain SFT distillation stays open. Cite the decomposition and the 8 of 8 win, not a headline jump. Distill only what transfers. Purified OPSD decomposes the teacher's update, isolates the reference memorization the student can never use, and keeps the inference transferable signal, which turns out to be the closed-form KL regularized optimum. 8 of 8 wins over both base and standard OPSD, epistemic markers preserved, under 10% wall clock overhead. The contribution is a clean diagnosis plus a principled fix, not a headline benchmark. Subscribe for the next breakdown.